Hi everyone, I am Stephanie Valencia.
And I'm Jessica Huynh, and we'll be presenting our work on COMPA, using conversation context to achieve common ground in AAC.
Our contributions include a user study and the introduction of a novel system titled COMPA.
Augmentative and alternative communication, or AAC for short, devices generate speech through specialized interfaces and input modes, such as touchscreens on the left, head switches in the middle, or eye trackers on the right. People with speech and motor disabilities may use these devices to communicate, but using these devices increases the time it takes to communicate, which creates a speed asymmetry between using speech and using an AAC device. This is especially prevalent in multi-party conversations. Let's go through an example where we have three participants, Jane and Alex, who are non-AAC users using speech to communicate, and Arlo, an AAC user using their AAC device to communicate. So Jane starts the conversation with, "Let's meet up in person to plan our summer vacation trip with the kids." Alex responds, "So I have a pretty booked day, but I could catch up with you both this afternoon." Jane then says, "Yeah, sounds good. Coffee? Are you both free around 2 p.m.?" And this is where Arlo starts typing a response. However, in the meantime, Alex moves on in the conversation and says, "That works, Jane. How are the kids?" And Jane responds, "The kids are great. They're excited for this trip." And so we can see a topic change from grabbing coffee previously to now talking about Jane's kids. And now Arlo finishes typing their response, and it says, "Yes." And so since we can see the transcript of this conversation in this example, we can infer that this yes refers to when Jane had asked if Alex and Arlo were free for coffee this afternoon. However, in a conversation setting without a transcript, one can imagine that an initial interpretation to this ambiguous reply of yes could be affirming Jane's statement that the kids are excited for the trip, since the yes was taken out of context. However, if Arlo crafts a longer response that grounds their statement with coffee, it would translate to more effort and more time, which induces more delay in their response. Both situations are not ideal, and while developing COMPA, we keep the idea of solving this out-of-context issue in mind.
To gain a deeper understanding of breakdowns in common ground during conversations and to explore opportunities for addressing timing and contextual challenges, we conducted two formative studies. First, we examined triadic conversations involving both AAC users and non-AAC users, and through this analysis, we aimed to pinpoint the specific context that AAC users sought to address within the conversation. We discovered that in 27 out of 34 instances we examined, the conversation context an AAC user was responding to was situated within the turn immediately preceding their input. This indicated that the typing activity would be a key indicator of finding this contextual relevant portion. We then carried out a 2-day and fully remote participatory workshop to explore the design space where technologies could help support context and timing challenges. Workshop participants included 2 AAC users with disabilities associated to speech production and who used a range of input methods, including custom touch-based keyboards and eye tracking. Other participants included 3 technology researchers with expertise in accessibility, HCI, and natural language processing, and 3 communication scientists. During the workshop, we invited the participants to engage in writing exercises aimed at brainstorming potential solutions. After discussing types of tools to develop, AAC users were split into teams with other participants to refine their ideas and share it with the rest of the group. Building upon the ideas discussed, AAC participants identified 3 primary focus areas. These included tools designed to facilitate speaking to specific topics and contexts, and they discussed the value of having specifically visualizations of conversation transcripts and conversation threads. Additionally, AAC users desired tools that could support the generation of creative and expressive vocabulary, and tools intended to provide cues to non-AAC conversation partners. Our 2 formative studies indicated possible directions for design. Mutual understanding is easier to maintain when both communication partners know more about the conversational context they each are speaking to. Similarly, AAC users in the workshop shared a desire to have more responsive AAC devices that could change suggestions based on ongoing context. We identified that a shared visualization of the conversation could help partners establish the context of an AAC user's message, as well as help the system generate relevant, creative, and useful vocabulary suggestions. We also know that partners can benefit from more signaling to be reminded of when and how AAC users want to participate in conversation. Our second design goal focuses on increasing partners' awareness of when the user wants to participate and how they wish to participate. Lastly, AAC users and partners cooperate with each other in conversation to achieve mutual understanding, so different tools should be created to support both types of users.
With these findings, we introduced COMPA, which uses context marking and phrase assistance in an add-on AAC tool that creates a common ground for group conversations. COMPA is a browser extension that can be linked to virtual meetings, and we use Google Meets for testing our extension. So COMPA consists of an AAC user interface on the left and a communication partner interface on the right. In our case, a communication partner is someone who is familiar with the AAC user who is also participating in the conversation. We will now go in depth to each of the functionalities in COMPA. First, we will look at the AAC user interface. Both the AAC user interface and the conversation partner user interface have the ongoing transcript of the conversation, but the AAC user interface has a transcript pausing functionality. The AAC user can either start typing or manually pause the transcript with the pause button, which will automatically pause the transcript for both them and their conversation partner. This will help signal to the conversation partner that the AAC user is responding to a certain part of the ongoing conversation. When the transcript is paused, both the AAC user and the conversation partner will see a context marking flag. This flag indicates how the AAC user wants to respond to the conversation. We can see 4 of these intents here: reply, opinion, question, and yes/no, which will change the text in the flag. Next, we have the text composition panel, where the AAC user can directly input a response, and the intent-specific starter phrases, which the AAC user can use to help them start a response. We define a starter phrase as a sentence fragment that can be the start of a valid response based on the previous context and the selected intent. We choose to create starter phrases and not complete sentences because it is very difficult to predict what someone wants to say in a conversation due to the fact that there are many valid responses for any given conversation context. We also wish to allow the AAC user to retain their personal expression while still helping them ground their response in the context they are responding to. As you can see in this example, the starter phrases are directly referencing Jane's statement of getting coffee later today without necessarily providing a complete response. The starter phrases were created by prompting ChatGPT with a conversation context and asking it to create 3 starter phrases with a limit of 6 words each. To recap on the conversation partner interface, they receive the transcript, which pauses anytime the AAC user pauses its transcript, and the context marker, which has 4 options that change the text in the context flag and indicates how the AAC user plans to respond to the flag sentence.
In this study, we wanted to understand how the different features of COMPA, the transcript pausing, the marking of the context, and the AI intent-specific suggestions impacted how much AAC users could participate in conversation, even in the face of fast topic changes. To study this, we created versions of COMPA with less features to compare the user's experience with each one. 5 pairs of AAC users and a conversational partner of their choice were invited to participate in a remote study to try out COMPA. AAC users and partners joined this study remotely and installed COMPA on their browser. A researcher acted as a moderator and led them through the conversational task of planning a summer vacation. The vacation planning task was split into 3 subtasks: deciding on a location for the vacation, deciding on the trip activities, and lastly, discussing who else to invite to the trip. The group completed each subtask with a different version of COMPA. The order of the subtasks remained constant during each run of the study, and the summer vacation task was chosen to simulate a natural conversation among 3 participants. In addition to being actively engaged in the conversation as a third participant that was helping plan the summer vacation, The researcher also introduced significant changes in the conversation, including sharing an unrelated anecdote and deliberately committing common errors that unfamiliar partners often make with AAC users, such as speaking while the AAC user is typing or asking multiple questions consecutively. In general, AAC and non-AAC communication partners had positive experiences using COMPA. An AAC user participant shared that COMPA's transcript pause feature seemed to help level the playing field, while a communication partner shared, "I think all versions each help keep everyone on the same page discussing a topic." Having the transcript pause allowed AAC users to be able to talk about any topic even when other participants in the conversation kept talking. Communication partners found it was easy to understand their AAC partners better with the transcript, but shared the conversation was easier to follow when the transcript marked the context of what the AAC user wanted to respond to. Communication partners found the intent-specific notifications to help the flow of the conversation. CP3 shared, "Knowing the context of our response is especially important when solving a problem together." CP2 also liked having more information about the AAC user's intention. "I enjoyed knowing what the AAC user is replying to, so I know what to expect and what kind of response I'm waiting for." Starter phrases were used when they contained contextually relevant words but were always edited by users. In one example, when the moderator was talking about seafood, AC2, an AAC user participant, selected the reply intent-specific phrase, "I am not a big seafood fan, but," and edited it to, "I am a big seafood fan." Other edits including selecting the COMPA starter phrase, "I love trying new things," and changing it to, "I love trying new food." And lastly, selecting, "What kind of food do you?" and changing it to, "What special food does your country have?" In this way, intent-specific phrases were helpful as they often included the current topic that was being discussed and allowed AAC users to provide more detailed responses that could establish the relevance of their messages. 3 out of 5 AAC user participants rated intent-specific phrases to be more useful than general starter phrases that didn't require the AAC user to select an intent. But while intent buttons generated starter phrases that were preferred by AAC users, there were some concerns around how a limited set of intentions provided by the interface could constrain the user's expression. As emphasized by AC5 and AAC user participant, presenting predefined limited intents in an interface can unintentionally convey a misleading message to an AAC user, suggesting an expectation for only specific intents from them. Even if the categories of intents available to a user are in the future predicted by a model, it is important the user can customize and override or have easy access to a myriad of intents to avoid unintentional, harmful messaging that all AAC users communicate in a similar way.
To conclude, we introduced COMPA, a web tool to facilitate multi-party conversations for AAC users and their conversation partners, which can be used with their current AAC devices. We address the out-of-context problem present in multi-party conversations with context marking, starter phrases, and intent-specific notifications for conversation partners. COMPA has been shown to be effective for improving conversational flow, and participants had generally positive reception toward COMPA. A majority would use COMPA in remote meetings. Thank you.